Can I develop a game in just 52 days? That sounds impossible. Yet after just 5 days, my game is already on Steam. This is the story of developing a strategic racing game where your only opponents are yourselves. A game about wrestling with your own decisions, about reflection, hesitation, and the struggle to do better. Now that's not what you expect from a racing game, I know. But I am not chasing trends. I am crafting thoughtful, meaningful games, built to be remembered. That is the kind of quality I miss in most releases today. If that sounds like an honorable pursuit, I'd love to have you on board. It all started on a Wednesday evening. Let me take you on a journey.
Welcome to GMTK Game Jam 2025. This is a crazy fast game-making marathon where you have just 4 days to make a game that fits a theme. And this year's theme is just one word: loop. Best of luck and have fun.
Now listen, Mark called this game jam a marathon, but to me, 4 days, that sounds more like a sprint. So in order to turn this into an actual marathon, I've decided to commit 1 day per week for the coming year towards turning Forca Recurva into a full game. So in this video, I'm not only covering my GMTK experience, I'm also covering the first 4 days of this 52-day journey. The game's already on Steam, ready to be wishlisted, and there's already a playable prototype for you to play. I'd love to have you join me on this 1 year-long journey. Links are in the description. Note that when I submitted the game to the Game Jam, it was called Ghost Racer. It's now officially called Forca Recurva, but you'll still see the old name pop up here and there during this very first episode. But now I do need to go and make this game, since I only have 52 days left. When I sit down to start a new game, I'm not really looking for a cool mechanic. Instead, I'm hunting for a rich, juicy problem space. A playground with so many levers to pull, push, twist, or break that the ideas kind of almost design themselves. If I can instantly come up with a dozen unique levels, then that's kind of when I know that I found that space. And that's around the time when it's worth opening the engine. But unless that space is found, I usually just stick to a blank sheet of paper, or screen in this case. Philosophy is my go-to hunting ground. So this time I started with life and death. Some people believe we're trapped in an endless loop, born and reborn again and again. Others believe we only got one single loop and that's it. A nihilist might wish to never even start their loop, skipping life altogether in order to avoid the struggle. And some people dream of transcendence, a kind of life after death, which in its own twisted way traps you in the same loop forever as well. But as much as I liked the life and death concept, I couldn't find a moment-to-moment gameplay that seemed exciting to me. The game 1 Hour, 1 Life nails that theme brilliantly already, so I decided to move on. Cooking is a big part of my life, and once food is digested, it needs to, be released. But that seemed a bit too gross for a jam idea, so I dropped it. Then nature came to mind. Cycles, loops. Rain falls, rivers flow, they form lakes, the water evaporates, forms new clouds, and the loop starts from the beginning again. A really elegant system. But then this poop idea came back. It turns out that, did you know poop rhymes with loop? So does soup, which means I could design a game where you would eat soup, poop, then use that as fertilizer to grow veggies and make more soup out of that. That would basically be a soup poop loop. I even imagined a mechanic where you would slide soup along a loop and then feed a character who then would use the loo to poop. And what's funny, if you actually pee into the loo, you also get loop. By the time I snapped out of it, I had already written down an extensive gameplay loop, but I realized I was no longer 6 years old. So probably time for something a little bit more mature. Next, I explored a side-scrolling platformer idea. The player would walk to the right and repeatedly dodge portals that would send them back to the start. Walking the same path over and over again felt repetitive, so I twisted the planar map into a ring. Parts of the ring would be outside of the screen area, letting the player move in the foreground while also seeing the other side of the ring in the background. That background area I called the preview zone. Elements could spawn outside of the screen area on the sides of the ring, which is what I called the forget zone. To finish a level, the player needed to reach a flag. And to ramp up complexity after each level, I increased the ring's size by appending parts inside the forget zone. This allowed gates and obstacles to appear dynamically. Players, for example, would walk into a gate and then had to change direction. These gates came in different colors, each requiring a different key to be opened. And this added a kind of puzzle mechanic to this whole side-scrolling idea. By the end, I had designed a sequence of about 6 levels, but the core gameplay loop was all about switching movement from left to right. That didn't seem very interesting by itself, and I really struggled to find more twists to tweak this idea, so it really didn't feel like a very rich problem space. Since the jam clock was progressing rapidly, I decided to block out a quick schedule to make sure I would stay on track. I made sure to block out time to sleep, since I need a good 6 to 8 hours in order to function. In the early morning, I then called it a day. That night, the concept fairy paid me a visit. I woke up at lunch, eager to see how far I could push my new idea. The pitch was simple: a racing game on a non-circular track. Each time you pass a checkpoint, you're sent back to the start. Except now, your previous run is racing alongside you. And with every checkpoint, a new ghost joins the track, and the chaos turns into mayhem. The inspiration for this came from Make Way, a party racing game where you and your friends race against each other from checkpoint to checkpoint while sabotaging each other. And I thought, what if we make that kind of game but we strip out the multiplayer and make it single player only? When I refine a new game idea, I like to start by specifying the core gameplay loop. That is the action you repeat from moment to moment. In a regular racing game, you could say that the core gameplay loop is probably racing fast and avoiding crashes. But in Ghost Racer, it's all about slowing down and leaving your future self enough room to breathe. Sometimes slowing down would make you faster later, and sometimes taking a detour could give your future self the edge. Once that was clear, I moved on to the secondary loop. Those are the actions you repeat often, but not all the time. In Ghost Racer, you're re-racing the same stretch of track over and over again. A checkpoint late in the race might take you up to a minute to reach, so keeping each reset interesting was crucial. One idea to improve that were power-ups, but with a twist. When you collect them, they don't activate immediately. Instead, they activate when your ghost picks them up in the next loop. That means you might pick up a boost only for your ghost in the next loop to activate it while you're trying to slowly navigate a track and then you race into the wall. Or you might purposefully sabotage a ghost by picking up a debuff, and suddenly this racing game became a strategy puzzle. Another idea was detours and keys. Maybe we could have dead ends, and when you drive into them, you would find a key, and those keys could unlock shortcuts which would stay open for future loops. That could keep setbacks from feeling repetitive. And of course, your ghosts are the main obstacle in this secondary gameplay loop. Unlike a scripted AI, these are literally your previous runs. So you had full control over how this race would turn out. It was perfectly deterministic, which is great if you want to design a puzzle game, because there is nothing worse in a puzzle game than random behavior. But still, every race could turn out differently based on your racing choices. But there was one big problem. All ghosts would always spawn in the exact same position as you. So I chose to make them non-collidable while you spawned inside of them. But that created an exploit. Since now you could just stay within your ghost and race the entire track within them. The fix to this was forced divergence, where I would give the player only a very short grace period where they would be allowed to stay within their ghosts. Then they would be required to have left all the ghosts bounding boxes, which would solidify the ghosts into physical existence. That way, every attempt quickly branched into a different path and strategy. And with that, the foundations for Ghost Racer clicked into place. When I start prototyping in the engine, I usually start with input. For the jam, everything had to work with mouse and keyboard. But for a racing game, a controller just feels better. So I leaned back and tried to imagine what driving a car with a mouse and a keyboard would feel like. I imagined controls for both types of devices. though controller inputs were much more straightforward. Now Unity has a way of making even simple things way too complicated, and input is no exception. I tend to stick with the new input system since the old one is even worse. So I set up the basic inputs, which were gas, brake, steering, as well as a button for using pickups. Unity has its own very opinionated way of wiring these events into code behavior. But out of all the options, their messaging system always feels like the least painful choice. Next, I dropped a flat plane into the scene and threw together a quick car model. For some reason, I painted it an awful shade of brown. I might have still been a little too attached to my previous poop soup idea, I guess. Anyways, before diving into physics, I decided to just throw on a rigid body component and apply some forces. Gravity worked perfectly fine, steering, however, not so much. I had to think a little bit more about how cars actually move. Turns out the back wheels are always fixed in place and the front wheels always point to where you steer. The rear wheels kind of chase the front ones while cutting corners along the way. That sounds obvious, I know, but I've never actually programmed a car before, and once you try implementing it, you realize that you never actually thought about it in detail. So I decided to implement the velocity vector myself, and of course something went wrong immediately. One of the wheels was mounted on backwards, which was made clear by this purple debug line which was sticking out in the wrong direction. It was Rebecca purple, to be precise, which I thought was an interesting name for a color. That little bug caused my wheel forces to cancel each other out, which caused my car not to move at all. Simply flipping the wheel fixed it. But then simply pointing the wheels in the direction of my steering turned my car into a sci-fi hovercraft. After a lot of fiddling with the wheels' rotation, they finally pointed forwards in the direction of steering as well as outwards, just like these red and blue debug lines show. Finally, I decided to move away from the poopy brown look and switch to a clean blue. I couldn't quite let go of the brown, so I kept it on the ground as soil. Next, I built a finished gate and set up a collider which would detect objects from entering. Then I set up a handler which made sure that the entering object was actually a car. If it in fact was a car, it would be set back to the starting position and rotation. To manage all the game's rules, I added a game mode which would keep track of everything. For now, it was getting notified when a car crosses the finish line. To my surprise, that worked first time, except for some lingering physics which carried over from the last loop and caused some glitches. But instead of fixing that right away, I wanted to push onwards and start building the ghost cars. For those, I went with the color red, leaning towards the classic red versus blue color scheme. Each frame, the player's position and rotation is recorded, and when the player crosses the finish line, a ghost would spawn and replay that data. Technically, this meant that for every single frame I had to loop over each ghost and loop over each ghost's recorded data to find the correct one. That scales as G times F, where G is the increasing number of ghosts and F is the increasing number of frames since the last lap. That's not exactly efficient, but I shelved the optimization for later. I did, however, cause a bug when comparing lap times, which caused my ghosts to get stuck in the finish line. Thankfully, that was an easy fix, and once corrected, my ghosts started racing. With that working, I added some on-screen stats to help the player understand how they were doing. Using Unity's UI toolkit, I added a loop timer, a race timer, and the current loop number. Personally, I'm not a big fan of Unity's UI toolkit. It borrows heavily from web development's layouting model, which I think isn't very well designed. If they really felt the need to copy someone's model, I would have preferred them to copy Windows Presentation Foundation, which you know isn't perfect, but back when I used it extensively about 10 years ago, it had far fewer flaws than the web-based model, which has since gotten even more complicated. Oh yeah, maybe don't buy this version, it's quite outdated. I also lowered the camera angle for better framing, and I added a big finish label to celebrate the last lap. By this point, my code was getting quite messy already, so I cleaned up by moving all the ghost-related code into a separate class. I named it Symmetry, which felt quite fitting. It was, however, getting quite late, so I wrapped up for the day. But before bed, I grabbed a snack, some cereal with milk. And no, this is not a product placement. I don't exactly have sponsors lined up. But if you'd like to follow this 52-day journey, then subscribing would mean a lot. It'll make sure you won't miss what comes next. But now it was truly time to go to bed. After waking up around lunchtime, I felt time slipping through my fingers, and I decided to map out my timeline more accurately. I quickly noted down the milestones we had covered already in blue. The night before, I had wanted to have a playable MVP ready. MVP in this case meaning minimal viable product. But the game simply wasn't there yet. The most pressing issues were ghost collisions and being able to finish and retry a race. Closing the gameplay loop became my top priority for this afternoon. I've always loved arcade-style leaderboards at the end of a game, and I thought Ghost Racer deserved one too. I grabbed my pen and started sketching out a scoreboard. I wanted to display a cumulative score as well as each loop individually. A crash and ghost counter was included too, but the UI looked quite bland, so I decided to add some color. And to encourage players to push themselves, I decided to add motivational phrases. For example, if someone would finish with a poor cumulative time, the game would display "winner winner, but still a beginner." If they would manage to beat the target time, the game would instead say "winner winner, no longer a beginner." Some of you will know that this wording is inspired by PUBG's winning phrase "winner winner, chicken dinner."
Oh my God.
Then came the implementation in Unity's UI toolkit, and oh boy, this took forever. The tool just kept crashing or displaying layouts incorrectly until I closed and reopened it. I was constantly second-guessing myself whether it was a mistake in my own layouting or whether the tool was simply acting up. And on top of that, I just kept iterating on the visuals, which elongated the entire process. Because the target score was meant to be tough to break, I wanted players to have a sense of progress even if they didn't manage to beat it. So I started storing the player's personal best in Unity's player prefs. These are perfect for storing game state during a jam, since they do not require file system access and therefore they work on web builds on itch as well. This way the game now always showed the player whether they were able to beat their previous record. Before I knew it, the evening had arrived and the jam had reached its midpoint. You probably know the feeling that on vacations the second half always passes faster than the first. And while I cannot confirm this for life itself, I do suspect the same is true. Either way, when I revisited my timeline, I realized that I had missed my goal by a large margin. But still, keeping track of time allowed me to reconsider my approach. To make things more official, I added a developer's best target time to the scoreboard. I also experimented with color coding the labels to indicate success or failure. But the colors just didn't feel intuitive, and after going back and forth, I settled on the version that confused me the least. Next, I added a countdown before each loop. This way, players had a chance to prime their input before the race started. I recently played the game Wheel World, and there the developers chose not to include a pre-race countdown. And that decision alone cost me about a second during the start of each race. Easy. Let's race. Okay. Oh god, it's immediate starts. Full speed, boys! At this point the terminology became quite confusing. In the code I had variables named race, loop, lap, cycle, abort, reset, restart, setback, checkpoint and finish. It was chaos. So I drew a diagram to clarify the individual concepts and assign them proper names. Here is what I settled on. A race contains multiple loops, and each loop starts and finishes. Moving the car back to the start is called a setback, which is triggered either by reaching a checkpoint or initiated manually. The final loop of a race ends at the finish line, which also ends the race. I then went through the code and applied this terminology, which made everything more manageable. Next, I naively mapped steering to the WASD keys. But when I tried driving like this, it felt terrible. But I shelved this issue for later and instead focused on clamping the turning speed of my wheels. This meant that no matter how fast you would move the joystick, your wheels would only rotate towards the desired direction by a maximum speed. This is especially noticeable when reversing. The green debug line here shows the desired steering direction, and the wheels would slowly animate toward their maximum angle to match it. To improve visuals, I added some detail to the wheels so that you could actually see them turning. I wrote a short program that compared the current wheel's position to the one from the previous frame. Based on the wheel's circumference, I was then able to figure out how much they should rotate. Of course, a few rotational bugs popped up, but by now I was used to them, so I was able to fix them quite quickly. The physics, however, were becoming a real pain, so I decided to disable them and switch to full manual car control. This completely broke gravity and collisions, but the driving was much better. I quickly noted down the next steps: fix collisions, refine the driving experience, build a track, and upload a first version to itch. There were still no sound effects and background music, but I decided that gameplay came first. Finally, I grabbed a snack, still no product placement, before turning off the lights and heading to bed. Today, I managed to get up before lunch. I sat down with a refreshing drink and adjusted the timeline to the current time. It was time to tackle the car physics and the driving experience. My research, which I should have done in the beginning, pointed me towards wheel colliders, which I had never used before. These can be added to each of the vehicle's wheels and come with several parameters. For example, the wheel's radius, which is required for proper function. Then the dampening rate, which specifies how quickly the car slows down when no forces are applied. And then the suspension distance, which specifies how much leeway each wheel gets to simulate an internal spring. When I tested this, my car went complete nuts. Turns out the setup is quite sensitive. The wheel colliders had to be children of the car's rigid body component, and all values had to stay within a reasonable range. The only problem was I had no idea what reasonable was. But now that I was using the official physics engine again, I could finally re-enable the collisions. I suspected that my wheels intersecting with the car caused problems. So I grabbed a car model from Unity where the wheels actually fit into the spaces of the car. The first test looked quite promising, although I wasn't quite sure whether the tight space was actually the source of the problem. And of course there were still rotational issues with the wheels, but since that has been a reoccurring issue, I'll skip the details. The physics overall started to feel pretty good, although they needed a bit more fine-tuning. That sent me into research about forward and backwards friction curves, which are defined by extremum, asymptote and stiffness values. Wrapping my head around all of that took a while, but it was worth it. The car felt much better immediately and much heavier as well. Maybe a little bit too heavy actually. Another issue were physical forces which were carried over from one loop to the next. So the car would simply start racing even while the countdown was still counting down. To fix this, I had to manually reset all the forces on my rigid body. The previous ghost mesh also looked quite out of date, so I replaced it with the new car model. That caused the player car to spawn on top of the ghost cars, but we anticipated that in the concept phase, so the solution was at hand. I made the ghosts aware of them intersecting with the player. Depending on whether or not they were intersecting, I swapped out their material from a transparent to a manifested one. That gave the player an indication of whether they were still intersecting with the ghosts or not. I also needed to toggle collisions. At the start of each loop, all ghosts would be placed in a trigger ghost layer, which disabled their collisions. Then I moved them to the ghost layer once they no longer intersected with the player, allowing them to collide again. Unity's collision matrix UI is surprisingly good, which is a rare statement for a Unity feature in my opinion. At first, it didn't work, ghosts wouldn't manifest and stayed transparent, but eventually I wired everything correctly and it was fine. Next, I added a setback function, allowing the player to manually set back to the start in case they got trapped. At first, the ghosts from a setback simply disappeared, but I changed it so they would linger around, much like a dead body in a shooter. Therefore, resetting in a bad spot would leave a big boulder in the middle of the track. I also kept ghosts lingering around after reaching a checkpoint. That meant you couldn't just blindly race through the finish line, you had to make some room for your next run. Another big issue, there was no reverse. This often left me deadlocked in a corner and I was forced to set myself back. My solution was to give the brake a dual purpose. Regular braking while regular driving, but reversing while standing still or already moving backwards. I used 3 different strength values for gas, brake and reverse, so that I could fine-tune each of them. With time running out, I created a basic itch page and uploaded a first build. That way everything would be ready and set up for submission, because at this point I had only about 24 hours left. I added a speed display to the rear window of the player's car and a warning telling players that they must leave their ghosts within 5 seconds. 3 seconds felt too short and 5 was alright kind of, but maybe still a little bit too long. Originally I wanted players to be able to build their own track piece by piece by selecting a segment after reaching a checkpoint, just like in Make Way. But reality set in. There simply wasn't enough time, so I re-evaluated my next tasks and scaled down. I was switching between input action maps, between laps and at the end of the race, which is a neat way of disabling all inputs and enabling a complete different set. But when switching to an action map, Unity doesn't pull the current value, so holding down the trigger while switching isn't properly recognized. And therefore, when a loop started and you were already holding down the trigger, no gas was applied. Mouse and keyboard inputs were still awful and I was missing a main menu, as well as more than one checkpoint. So I modified the game mode and extended the track after reaching a checkpoint. I placed 3 checkpoints and built a simple track to test this out. I informed visitors to the itch page about the controls, since that is where most people seem to look for them, and also painted them on the ground at the start of the race. To better visualize race progress, I added a counter to the left of the starting position, which would increase with every loop. For the main menu, I piled a couple cars on top of each other and added the title Ghost Racer. Then I pulled a little twist by coloring it so that it actually read Ghost Pacer. That seemed like a fitting title too, since I often felt paced by the ghosts, either slowing down or having to speed up to evade them. By now I was using 3 different action maps, and I added a 4th one to initiate the transition from the main menu to the race. With 15 hours left on the clock, it was time for bed. I managed to get up before lunch again, but now there were less than 8 hours on the clock. My very first task was to submit the project. After submission, you can still upload new versions until the jam ends, so it was more about crossing that psychological milestone. I revisited yesterday's checklist and was proud about the progress I'd made the night before. But input was still a big issue, so the top priority was mouse and keyboard controls. In my opinion, Halo always had excellent vehicle controls, even on PC, so I decided to borrow their system. When using a controller, the camera currently already follows the car automatically. But in Halo, when using a mouse and keyboard, you steer by pointing the camera in the direction you want to drive. That meant I had to make the game aware of which input method was used and switch the camera between manual and automatic control. The solution I found was simple. If the game received controller trigger input, it switched to controller mode and therefore automatic camera movement. If the game received mouse movement, the game switched to mouse and keyboard mode with manual camera movement. You could now swap between devices at any point while playing without having to visit a single menu. Steering also needed changes. With mouse and keyboard, the car would now always steer in the direction of the camera. And on controller, the car would steer in the direction you point your stick, independent of the camera. So the mouse could now orbit the camera around the car. Of course, this didn't work the first time. The tricky part was getting the camera to orbit correctly while the car was in motion. But I got there eventually. From past jams, I knew that everyone uses wildly different mouse sensitivities. So I added adjustable mouse sensitivity mapped to the mouse wheel. Next, sound effects. I added a car unlock sound at the start of the race, 2 different countdown beeps, a ding for hitting checkpoints, and an error buzz for setbacks, as well as an applause for celebrating the finish. I also sped up the countdown that plays after reaching a checkpoint. At the very start of the race, you will likely need a second to get into the zone, but mid-race after checkpoints, you're already locked in. I also tested having no countdown at all after checkpoints, but that just felt a bit stressful. After testing the controls for a while, I realized that precise turning was still quite tough. It's just hard to judge the exact camera angle. That's when I remembered Halo's tiny guiding marker at the center of the screen, which I always underappreciated. I shamelessly copied that idea and added a guiding line to the ground. I was really short on time, so this was simply a text box containing a bunch of L characters separated by line breaks. The game still needed music, so I found this great background track while searching online. I also swapped in a better font to style the text. I wasn't thrilled with my font choice, and the font couldn't even display the E with the 2 dots from my name, Noël, properly. So I replaced the E with a regular E, which is often a good choice anyways, since it makes people more confident saying my name out loud. With time running out, I reassessed my priorities. A racetrack was still missing, but instead of doing that, I procrastinated by beautifying the checkpoints. Only then did I begin to build the actual racetrack. As a fun little detail, I added the cars from the cover art on a small pedestal in the middle of the track, where players could drive past. With something that resembled a racetrack, I built and prepared to upload. Less than 1 hour remained at this point, and I knew that itch would likely collapse in the last 30 minutes, since there were so many people trying to upload their game. I really just wanted to beat that rush hour. But the build just wouldn't complete. It ran way longer than before, and I couldn't cancel it either. So panic started to set in. I killed the build process after about 10 minutes and suspected that my build settings might be the issue. I had very recently switched code optimization to favor runtime speed. I reverted it back to favor faster builds and tried building again. 40 minutes left. Luckily, this time, the build completed within 2 minutes. But it failed with an error message I've never seen before. So I tried again, same error. I assumed that killing the process earlier might have corrupted some cached data. So I rolled back some more changes, including the IL to CPP code generation setting, but nothing worked. I restarted Unity, deleted the library folder, which forces a cache rebuild, and lost even more precious time. Finally, with less than 30 minutes remaining, I got another build running. My heart was pounding, and after 10 minutes, I cancelled the build again. But this time, it cancelled immediately, so something was clearly different. So I tried building again, and miraculously, the build successfully completed within 2 minutes. And with only 16 minutes remaining, I uploaded a working version of the game. Relieved, I simply sat back and started playing the game without the worry of a running clock. But that's when I noticed a major issue in the timer display. With less than 10 minutes remaining, I dove into the time formatting function. My brain was complete mush from these 4 days, and I kept chasing phantom mistakes. Until I realized the actual bug. I wasn't subtracting the full minutes from the seconds. So once the timer passed 60 seconds, it just displayed nonsense. With less than 3 minutes remaining, I started yet another build. My hands were really sweaty at this point. I mentally went through the exact mouse movements required to upload this next build before the deadline. But the clock hit 0 while the build was still running. At least I got to upload a full racetrack before the timer hit the deadline. That's when I saw a new tweet from Mark exactly 11 minutes ago informing us that he had extended the deadline by 1 full hour since itch had collapsed under the pressure. 2 minutes past the original deadline, I uploaded my next version of the game with a working time display. And due to Mark's extension, I was even able to add some minor details to the track to guide players through an optional small puzzle element in the track. With 12 minutes left on the clock, I uploaded my final version of this game for the Jam and stepped away from the keyboard. To this day, I'm still not sure at all what caused all of these build issues, but I learned my lesson. Never mess with the project settings near the end of a jam. In this video, I covered the first 4 days of this 52-day journey. In the next episode, I'll dive into player feedback and the next iteration of the game. In the meantime, you can wishlist the game on Steam, play the prototype on itch, or join the Discord to support the project. There you can share your best times and earn medals if you break into the top 3. And since it is a brand new server, setting a new world record might not be too difficult for now. All the links are in the description. Those medals, by the way, are laurel wreaths, and they will play a central role in Forca Recurva. More on that later in the series. If you've enjoyed this format, a like helps more than you think, and subscribing will make sure you'll be here when this journey continues. Thank you for watching and caring about the craft. Until next time, take care.